Ni hao. My name is Sahdev Zala. I am an open source contributor, developer at IBM, and I contribute to Kubernetes. I'm a co-chair for this project called Provider IBM Cloud, which is a sub-project of Kubernetes Special Interest Group Cloud Provider. I'm also a maintainer for the etcd project. Richard, would you like to introduce yourself, please?
Ni hao, I'm Richard Theis. I work on the IBM Cloud Kubernetes Service and Red Hat OpenShift on IBM Cloud Managed Services. And also I co-chair of the Provider IBM Cloud, working on primarily our Cloud Provider component for the IBM Cloud Kubernetes Services.
Thank you, Richard. So welcome to this talk. The agenda, it's a light agenda. We'll talk more, a lot more. I think I will provide an overview of the SIG Cloud Provider and about this Provider IBM Cloud sub-project, the structure and activities, and then talk a little bit about the cluster API Provider IBM Cloud, which is one of the Git repository we have under this project, and then we'll talk about IBM Cloud Provider. Alrighty, so SIG Cloud Provider is one of the special interest group in Kubernetes. It owns the code for the Cloud Provider interface and related work. So as you may know, that for Kubernetes to run on a provider specific cloud, it needs certain functionalities that are provided by control loops. For example, for the node to find the zone and IP or load balancer related control loops. So these control loops were part of the Kubernetes core, but eventually the community thought it's good to decouple it from there. So that's where the Cloud Provider interface comes in picture. It is now hosted on the GitHub repository on its own, on the Cloud Provider GitHub repository. And the Cloud Provider interface is responsible for running all the Cloud Provider specific control loops. Richard will talk more about architecture based on this called CCM or Cloud Controller Manager. But for now, continuing with Cloud Provider SIG, it also owns all the sub-projects. They were formerly owned by different SIGs. There were like 6 dedicated SIGs for different cloud provider. For example, SIG AWS or SIG Azure or SIG GCP or SIG IBM Cloud, and there were one for OpenStack and VMware as well. So these are all now part of the SIG Cloud Provider, and there was some renaming as well, and that renaming. Part of the renaming, the project, which was formerly known as SIG IBM Cloud, is now called Provider IBM Cloud. So the SIG Cloud Provider also ensures that the Kubernetes ecosystem is evolving in a way that is neutral to cloud providers, right? So it makes sure that there is no such thing like favoring one provider over another provider. It also ensures that there is a consistent and high quality user experience across different providers. As part of the SIG policy, the chairs of SIGs, there is only one chair from a single company. So, there can be 2 chairs or even 3 chairs sometime, but they make sure that they are representing different companies. You can find more about the SIG and all the sub projects it owns under the GitHub repository, where it's under Kubernetes community GitHub repo. So please take a look over there to learn more about the SIG. Alrighty, so the Provider IBM Cloud. As I said, it's a sub-project of Cloud Provider SIG, and the purpose of this sub-project is to build, deploy, maintain, support, and use Kubernetes on IBM Cloud. So we have IBM Cloud Kubernetes Service, which Richard will talk later when he talk about the IBM Cloud Provider, and he will talk about the Red Hat OpenShift Kubernetes Service as well. So, as a member of this subproject, as a participant of this subproject, you basically, obviously get in touch with many developers and leaders from IBM who have work on building the IBM clouds and, work on operating the IBM clouds, right? And you can follow the evaluation of the IBM cloud platforms with respect to Kubernetes and related CNCF projects, right? So this project is a platform to discuss things around Kubernetes and related CNCF projects, and the repositories, like I mentioned earlier. It is not a platform or a project to discuss any commercial product-related discussions or anything like that. All right, the SIG structure, there are 3 co-leads. Khalid Ahmed, who is IBM Distinguished Engineer, who leads the team on Multi-Cloud Manager. Richard Theis, who is representing IBM Cloud Kubernetes Service, and ROCS, or Red Hat OpenShift Kubernetes Service, and myself from the open source software development side. I actually work with the Kubernetes community on different things. There is a mailing list, so you can be part of the mailing list and stay on top of any communication happening there. There is a Slack discussions available on provider-IBM Cloud Slack channel. It's one of the channel on the kubernetes.slack.com. So we would love to have you join there if you haven't participated before. And if you're already participating there, thank you. We love you so much. You can learn more about the project again on the Cloud Provider page on the GitHub Kubernetes community repo. All right, so what are the different activities that we have as part of this subproject? So we meet every month. So every last Wednesday of the month, we have 1-hour meetings at 2 p.m. Eastern time. We used to have weekly meetings, but starting this year, we changed it to monthly because we have many other platforms of discussions, as I mentioned, Slack, mailing list, emails, whatnot. If you're in different time zone, if you cannot attend the meetings, that is totally fine. We record all the meetings, and all the recordings are made available on the Kubernetes YouTube channel. So here is a link. You can access the past recordings there. We also participate in the SIG Cloud Provider general activities, of course, as a subproject of the SIG. That's where we belong. Right, and there are 2 main items as far as code is concerned, as far as the real work is concerned. As part of this project, I would like to mention the first one is Cluster API Provider IBM Cloud. So as you probably already know, there is a Cluster API project in Kubernetes. It basically brings declarative Kubernetes style APIs to cluster creation, configuration, and management. And the IBM Cloud's particular project that we own under this subproject, it's basically an implementation of the Cluster API project of Kubernetes, right? So as I mentioned, it provides optional functionalities on top of the core Kubernetes to manage the lifecycle of a Kubernetes cluster. You can learn more about this subproject and the code at the GitHub repository, which is on github.com/kubernetes-sigs, Cluster API for IBM Cloud. So please visit there. Let us know if you have any questions on the Slack channel or mailing list or anything, by any other mean. The second thing is IBM Cloud Provider, right? So the support for out-of-free IBM Cloud Provider is under progress. Internally, we already implement the CCM. As I mentioned earlier, the Cloud Provider interface, enables that CCM architecture. So we already have that internally, but Richard will talk more about the plan going forward with the IBM Cloud Provider. So with that, Richard, to you, thanks.
All right, very good, thank you. So yeah, I'll run at a high level here over the managed services and then how the cloud provider fits into those. So we'll first start with our first service that we provided, which is the IBM Cloud Kubernetes Service, a managed service offering to create Kubernetes clusters, as you would expect. It's a certified Kubernetes offering through the CNCF Kube certification program. And if you want more information about this service and using it, you can check out that link there. But basically, it's a Kubernetes service, and in that we implement our IBM Cloud Provider to provide the cloud functionalities for the Kube clusters that you create. So next slide, please. So then our IBM Cloud Kubernetes service has provided 2 releases this year in 2020, 117 and 118. Kubernetes, on the other hand, has provided the 118 release this year and working on 119. Normally there's 4 releases a year, and there's been a couple things going on that has impacted 2020. Of course, the global pandemic has made a lot of changes to life, and the Kube community has adjusted as well. And there's been a lot of feedback from user communities and developers on and other cloud providers on the speed at which Kubernetes moves as far as the releases are concerned. So normally with 4 releases a year, you end up out of support from Kube community in less than a year if you're not staying up on the current releases. So it can be pretty daunting tasks for some to keep current with that pace. So there's been a lot of discussions in this area about the need for maybe long-term support or adjusting the release life cycle and support cycles. So this is, while not directly impacting the cloud provider SIG, but it certainly impacts all the cloud providers as far as the service they provide, building on top of Kubernetes, whether it's a managed offering or a product, if you will. So I've laid out on this page our latest releases, as you can see, when they were provided and when they are unsupported. And we release the versions of Kube usually about 45 days after the community, so you can get an idea of when Kube released their versions. So this is pretty quick speed at which to keep up. So if you're interested in more about the topic on Kube releases and patching and release lifecycle and potential changes there, please reach out to folks on the working group LTS channel, and there's some links on that channel as well if you're interested. For the cloud provider, there's interest in extracting all of the code from Kubernetes codebase that has lived there for quite a long time to move all of the cloud provider code out of a tree. IBM, we never had our cloud provider in tree. So by the time we got to the show, they were not adding cloud providers in tree, so there's no need for us to move. So it's more about our plans on open sourcing what we have today, which we run as part of the Kubernetes service here. All right, next slide, if you will. So we also have the Red Hat OpenShift on IBM Cloud managed offering. So OpenShift, if you're not familiar, is built on top of Kubernetes and provides these additional features and functions you get with Red Hat's OpenShift management or their container application service. So we provide that as a managed service on IBM Cloud. And you can see the versions that we have listed on the slide as well, 3.11 and 4.3. And in fact, today we just released 4.4. So that I haven't updated the documentation yet. But anyway, so those are available. OpenShift 4.3 is certified through the same certification program that we have for our Kubernetes service. and it's based on Kubernetes version 1.16. So if you look at OpenShift documentation from Red Hat, you'll see that they move at quite a fast pace as well, just like the Kube community as far as releases are concerned. So if you're interested more and would like to learn more about OpenShift, please check out that link there. All right, so now let's get into what is the cloud provider. What does it provide for Kubernetes? So you may hear us say the term CCM, that stands for the Cloud Controller Manager. This is the current architecture on Kubernetes for managing and working with the cloud. This is done through the Cloud Controller Manager, which has the main control loops. So the Cloud Provider SIG is responsible for owning those primary control loops. And then the cloud providers themselves implement the interfaces that the control loops use in order to contact through the cloud connector the cloud resources that it needs. So for IBM Cloud Provider, we run our Cloud Controller Manager in the control plane alongside the Kube Controller Manager, the API server, and scheduler, and etcd, and all of that. And then we, from there, connect off to the cloud, IBM Cloud, of course, and make the application calls that we need to implement various features of Kubernetes. And that way, it leaves the worker nodes, they're kind of hands-off from the cloud connections, which they used to be hands-on, meaning they all would work directly with the cloud. Now there's a little bit different approach here with this new architecture. Next slide, please. So then if you roll back that even further and look under the covers at what the interface is and what a cloud provider provides, there's a lot of different things, but these are the main ones. And you don't have to implement all of them. And in fact, you can write your own cloud provider to run on top of any cloud really that you want and make it be whatever you want it to be. For the IBM Cloud Provider that we provide with our managed services and that we'd love to open source is it provides two main things. Number one, it provides load balancer support for Kubernetes load balancers. And depending on whether you're running on a classic infrastructure or a VPC infrastructure, you get different types of load balancers. So for classic, you have a network load balancer that runs within the cluster. It's either IP tables based or IPVS based, depending on your configuration. And then on VPC infrastructure, you get a VPC layer 7 load balancer. So when calls are made for Kubernetes to create a service, that call is then sent off to the cloud provider, and the cloud provider goes and makes the calls to do whatever it needs to do to create that load balancer for you in your cluster. So that's one of the primary roles. The other important role for the cloud provider is to provide data about instances or nodes in the cluster. So we in the IBM Cloud Provider, we actually we work a little bit different than probably you'd find in a lot of other cloud providers in the sense that we rely on the infrastructure layer to do some bootstrapping of the node, and we grab that data from the node labels to populate the instance data that is needed for Kubernetes. So for example, you may want to know, Kube wants to know what region or what zone is a node in so that it could properly attach labels. You know, what's the other information from the cloud provider that it needs, such as IP addresses and such. So that data is provided through the instances interface. And now at 119, the community's implementing the instances v2 interface to try to streamline the connections to the cloud. So we'll be looking at implementing that in the cloud provider as well. The other interfaces, the zones one is tied to instances and load balancers. And it's very similar in that structure. We do not implement clusters or routes interfaces. As far as routes are concerned, we rely, and our managed services rely on Calico to provide the implementation for the CNI and do the routing within the cluster. So as a cloud provider, you're free to pick which interfaces you choose to implement or not, and what features you provide through that. All right. Next slide, please. So then just to wrap things up, what are we looking at towards the future? on our cloud provider. Well, we for sure work with the community and kind of keep pace on what's going on the SIG cloud provider front. So to that end, we'd like to open source our cloud provider for folks that are interested in using the IBM Cloud Provider outside of our managed services, right? And then to that end, we'd have to prove some documentations on how to set up your cloud provider. And then we continue working on aligning our build, test, and release processes with the community. So there's ongoing discussions with all the cloud providers about what's the best way, for everybody to be consistent about how they should build their cloud controller managers. Where should they submit tests, and how should that be done? And what should versioning process look like? So there's some consistency across cloud providers. So those discussions are ongoing, and they impact all the cloud providers, and we continue to make adjustments on ours to handle things like what was in 119 to provide a new instances v2 interface. So with that overview of IBM Cloud and our subproject of SIG Cloud Provider, would like to say thank you, and I'll turn it back over to you, Sahdev.
All right, unmuting myself. Well, that was great, Richard. Thank you so much, and thank you so much, everyone, for watching this video. Please reach out to us through Slack channel or through mailing list or emails. As we mentioned earlier, we would love to have you to contribute to the project and making it better, making Kubernetes better. So thank you so much. With that, I'm gonna stop sharing, Richard, unless you have anything else to talk.
Nope, nothing else. Thank you.
All right.